Hey everyone, and welcome. Today, we're going to dive deep into the story of artificial intelligence. You hear about it everywhere, but how did we actually get here? Well, it turns out it's a story that comes in three distinct waves. So let's start with the big one, right? How does a computer actually think? I mean, have you ever really stopped to wonder about it? You ask an AI to find a photo, write a sentence, or recommend a song. What is actually happening inside that machine? Well, here's the thing. There isn't just one single answer. The way we've tried to get computers to think has totally changed over the years. It's not a straight line of progress. It's more like a series of revolutions, with each one rethinking what came before.
Okay, so first things first, AI isn't just one thing. It's a huge umbrella term, It covers all these different ideas and technologies that have been bubbling up for decades, each one with its own unique approach to creating what we call intelligence.
So if we need a solid definition, this one from the European Commission is a pretty great place to start. Let's break it down. It's basically any system that can 1. Analyze its surroundings, 2. Make a decision on its own, and 3. Take some action to hit a specific goal. Simple, right? But those three parts are absolutely key.
So here's how we're going to tackle this. We'll look at the story of AI in three parts. First, the old-school symbolic AI. Then, the machine learning wave that's all around us today. And finally, we'll look ahead to what might be next, the more speculative stuff. All right, let's dive into wave number 1, what I like to call the AI recipe book. This was the dominant way of thinking about AI for like 40 years, from the 50s straight through the 90s. And yeah, it's got a pretty great nickname. Yep, experts literally call it good old-fashioned AI, or GoFi for short. The whole idea here was pretty straightforward. You take a human expert, figure out everything they know, and then just painstakingly program all of that knowledge into a machine. Seriously, it is all about the rules. The intelligence here wasn't about the machine learning anything. Not at all. It was just a super obedient follower executing a bunch of step-by-step instructions that a human had already figured out.
And this is what that logic looks like at its core. Super simple if-then statements. If this happens, then do that. Like, if the light is red, then stop the car. Every single decision was broken down into these tiny, crystal-clear instructions. Each one is like a single line in a recipe.
So the recipe book analogy is just perfect for this. Imagine you have the world's best chefs. Those are your human programmers. They write down every single step for every single dish with zero room for error. The AI, it's the cook in the kitchen who can't improvise, can't taste, can't do anything creative. All it can do is follow that recipe, but it can follow it perfectly 1,000,000 times a second. Now, this recipe book approach had a huge upside. It was totally explainable. If something went wrong, you could just open the book and find the exact line in the recipe that caused the problem. But there was a massive downside. It was super brittle. I mean, think about it. How would you write a recipe book to describe every possible situation on a busy highway? It's just impossible. The real world is way too messy.
And that brittleness is exactly what led us to wave 2, the learning brain. This is the stuff that's behind basically all the AI you use today. And it didn't just tweak the old model. It threw the entire recipe book out the window.
Okay, this slide cuts right to the chase. In wave 1, humans wrote the rules. In wave 2, the machine finds the rules. We stopped trying to be the master chefs. Instead, we gave the machine a massive library of finished dishes, that's the data, and told it you figure out the recipes on your own.
So instead of following a strict recipe, this kind of AI learns from examples. It's much more like how we learn, right? No one gave you a rule book for what a dog looks like. You just saw a whole bunch of dogs, and eventually your brain just got it. That's exactly what this new wave of AI does.
And this is a peek under the hood at how it works. This is called an artificial neural network. And yeah, it's loosely modeled on how our own brains are wired. So you feed it some data on one end, the input layer, let's say a picture of a cat. That data gets crunched through these hidden layers in the middle, where all the magic happens. And then out the other end, the output layer spits out a decision. Yep, that's a cat, or nope, not a cat.
You've probably heard the buzzword deep learning 1,000,000 times. It sounds super technical, right? But honestly, it's a pretty simple idea. Deep just means the neural network has a lot of those hidden layers we just saw. That's it. More layers means it can learn way more complicated stuff. It's like going from a brain that can spot a circle to one that can appreciate art. Okay, so we've got the recipe book, and now we've got the learning brain. So what's next? Well, that brings us to wave 3, the next frontier. And this is where things get a little more sci-fi.
The big goal here is something called artificial general intelligence, or AGI. All the AI we have today is narrow AI. It's amazing at one thing, like playing a game or recognizing faces. But AGI would be different. It could reason, problem solve, and learn across any domain, kind of like a human can. And let's be super clear, we are not there yet. This is still purely theoretical.
So how would we even get to AGI? Honestly, nobody knows for sure. It would take a breakthrough on the scale of, well, inventing the first computer. Some of the big ideas being thrown around involve things like advanced evolutionary algorithms, harnessing the power of quantum computing, or even, and this is a wild one, perfectly simulating an entire human brain. So, we've got our recipe book, our learning brain, and this far-off idea of a super brain. But why does any of this actually matter? Who cares how the AI works as long as it works? Well, it turns out the how is probably the most important part of the story.
And it all comes down to this fundamental trade-off. Remember the recipe book AI from Wave 1? It was crystal clear. We could always see exactly why it made a decision. But the learning brain from Wave 2, that's a different beast entirely. It's way more powerful for sure, but we run into something called the black box problem. Its internal logic can get so complicated that even the people who built it can't fully explain its reasoning.
And this black box thing, it's not just some academic problem. It has huge, real-world consequences. I mean, think about the really high-stakes stuff, right? Like an AI helping a doctor with a diagnosis, or a self-driving car making a split-second decision. If we don't know why the AI is making a certain choice, can we ever really, truly trust it? And if it messes up, how on earth do you even begin to fix a problem you can't see? And that's really why knowing this stuff matters. Understanding the how, knowing the difference between a simple recipe follower and a complex learning brain, is what gives us the power to ask the right questions. It lets us see past the hype and really get a handle on both the amazing things these systems can do and, just as importantly, where their limits are.
So that's what I want to leave you with. We've seen this big trade-off, right? Between the simple, clear recipe book and the powerful but mysterious learning brain. To me, the biggest challenge for the future of AI isn't just making it more powerful. It's figuring out how to bridge that gap. As these systems get smarter and better at learning about our world,